Okay, so yesterday we talked about scientific notation with very large numbers like distance the sun is to different planets in our solar system. Well, today we're going to talk about using scientific notation with very small numbers. Okay, by very small numbers I mean numbers that are several places away from the decimal point. But just like yesterday, there are certain things that remain true for this. For example, you still need to have only one number left of the decimal point. So if I were to write a number in scientific notation, as a reminder, you need to write 5 or one number to the left of the decimal point. So again, this could be any number like 2, 7, 3, 4, but it cannot be two numbers. Like I could not write 15 here. And then a couple numbers to the right of the decimal point, followed by the multiplication symbol with the number 10. And now the difference between today and what we talked about yesterday is the fact that when dealing with very small numbers, we are going to be using a negative exponent. So this could be something like -4. So if you see a -4, that means you're dealing with a very small number, or a number that's usually in the decimals. Okay, so taking a look at the problem we have up here on the page, we have a number, it's decimal point with a bunch of zeros, 5, 6, 8. Now, like we did yesterday, it's all about moving decimal points. So we need to move this decimal point so that there's only one number to the left of the decimal. Okay, so I look on the number and I find where that is, and I see that it's going to be between the 5 and the 6. So I want to move my decimal point right there. And again, the reason why is because there's only one number to the left of the decimal point. If I moved it between the 6 and the 8, you can see I now have two numbers to the left of the decimal point, and that is not correct. So find where there's only one number to the left of the decimal point. Again, count how many times you had to move it. 1, 2, 3, 4, 5, 6, 7, 8 times. So now, like yesterday, we just rewrite this as 5.68 times 10. How many times did I move the decimal point? Well, I moved it 1, 2, 3, 4, 5, 6, 7, 8. And then this time, -8 is your decimal, is your exponent value. Okay? So, again, to review, move the decimal point until you get it to where there's only one number to the left. Count how many times you move your decimal point. Give that the negative exponent. Okay? So, using scientific notation for objects that are very small, for example, like the width of a hair, length of a mitochondria inside a cell, and possibly weight of an atom, okay? Or like an electron or a neutron, things like that. So what you're going to do is you're going to move the decimal so that there's only one number to the left. So let's take a look at these two examples, okay? So here's the decimal point right now. We want to move it so that there's only one number to the left. Well, where is that? Well, in this one, it's going to be right here, between the 4 and the 5, because there's only one number to the left. So 1, 2, 3, 4, 5, 6, 7. 7 times. Rewrite this part of the number. These zeros I'm not concerned with. Okay, so rewrite 4.5 times 10. 1, 2, 3, 4, 5, 6, 7 to the -7. Okay, take a look at the last problem. Okay, again, decimal point, we're dealing with a very small number. Okay, we want to move the decimal point so there's only one number to the left. Okay, and that point would be right here. Now, count how many times. 1, 2, 3, 4, 5, 6, 7. Rewrite just this part of the number. Again, I don't care about the zeros. So it's going to be 3.67 times 10. 1, 2, 3, 4, 5, 6, 7 to the -7. Okay. So again, to review, all you have to do is move the decimal point so that there's only one number to the left. Okay. Then count how many times you move the decimal point. That is your exponent. And remember, because we're dealing with a very small number, it's going to be a negative. Okay.